Hello students, I am your teacher, your guardian, your mentor V K Singh. So we are continuing our discussion in the current electricity with lecture 3. Today we will discuss and continue our discussion in the series and parallel combination of resistors with some more examples so that the clarity of concept becomes even more clearer to you people. So let us discuss the current electricities, series and parallel. First question, to understand the series and parallel concept, what I would like to tell you, let us analyze this question. Let us analyze this question. There is a RAB. All resistances are R. Suppose this is the question and we have to solve this question. We have to find the equivalent resistance between A and B. Now if you don't have the clarity of concept of the series and parallel, you cannot solve this question. But if the clarity of concept of series and parallel is there with you, you can solve it in a very comfortable way. Let us try to see. These two resistors are in series and these two resistors are in series. So equivalent diagram, what can we make? We can make the equivalent diagram in this way. This is 2R, why? R plus R 2R, this is 2R, R plus R 2R, this is R, this is R, this is R, this is R, this is R. So these two resistors has been replaced by this single resistor 2R. Now next thing is there to understand, these two are in parallel and these two are in parallel. So what we are getting? For this we can get product 2R into R by 2R plus R, product by sum, that is 2R by 3, 2R by 3. So 2R by 3. So this can be replaced, these two can be replaced by the 2R by 3. So next diagram we are getting in this way, that so we are getting, this is also 2R by 3 and this is also 2R by 3, 2R and R parallel, 2R and R parallel. Now these are in series. So what we are getting? 2R by 3 plus 2R by 3, that is 4R by 3. So this can be replaced by 4R by 3. So next diagram will be in this way. This is your 4R by 3 R, R, R. So 4R by 3 and R are in parallel. So again product by sum, that is 4R by 3 into R by 4R by 3 plus R. This is giving you 4R by 7. So you are getting 4R by 7 for these two resistors. And now next thing is there, we have A, B, 4R by 7 and R and R. Now 4R by 7 and R are in series, so you will be getting 4R by 7 plus R, that is 11R by 7. So these two resistors can be replaced by 11R by 7. So you are getting 11R by 7 and this is R, and these are in parallel. So final result is what? Final result is 11R by 7 into R by 11R by 7 plus R. This is giving you so 11R by 18, provided the calculation is correct, 11R by 18 is the correct answer for this resistor. This combination of resistor is the equivalent resistance is given by 11R by 18. So see, if the clarity of concept of series and parallel is not with you, you cannot solve this question. Again, you see, all the resistors have the equal value R, 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 and then these two are in series parallel to this, these two are in series parallel to this. So we are getting this equivalent diagram. Now this is parallel, so we are getting this equivalent diagram. Now these two are in series, so we are getting this equivalent diagram, and then we are getting this equivalent diagram because these two are in parallel, so we are getting this one, and the final result is 11R by 18. So this will help you in building the concept of your series parallel combination. Here series is also there and parallel is also there. Now we will move to the next question. Second example. Here you see the question. The resistors are connected in this way. When the resistors are connected in this way, this question is very simple if you understand the hidden concept. What is that? This is a wire, so everywhere the potential is same. That means if this point is B, this is also can be treated as B, this can be also treated as B, this can be also treated as B. So 2 points are there. One point is A and one point is B. And between A and B, 1, 2, 3 resistors are there. Between A and B, 1, 2 and 3 resistors are there. Now you understand, they all are in parallel, so the answer will be R by 3. R by 3 is the equivalent. R by 3 is the R equivalent. Now we can extend the same question in this way, that for example 3. Now see this question. Every value is R, 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 R. In this question, now it becomes simpler. Similar to the earlier problem, here is the point A, here is the point B. Between A and B R, this point is B, so this point is also B, so this point can also be treated as B, this point can also be treated as B, and so we have got R, 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 and we are getting R by 4 is the equivalent resistance. We are getting R by 4 is the equivalent resistance. So this type of simple questions can also be helpful in clarifying your concept about series and parallel. Now we will move to the next question. Example 4. Now see this question. Here you have to find RAB across AB, and this is the connecting wire. When this is the connecting wire, R equivalent resistance, how can we find? A is there, B is there, but you cannot take here B because the resistance is R, so potential drop will be, so this point cannot be treated as B. Here also B is there, you cannot take this point as B because the resistance is R, so potential drop will be taking place. So what we will do in this way, that we will consider this point as X. As it is connected by wire, so throughout the potential will remain same, so it will also become X. When it is also X, it is also X, then there are 3 points. One, here is the A, here is the B, and here is the X. Between A and B, there is one resistance R. Between A and B. Between B and X, one resistance R. Between B and X, one resistance R. So here B and X resistance R. Then between A and X, one resistance R. Between A and X, one resistance R. So this is R and R, R by 2. This is R and R, R by 2. So R by 2 and R by 2 are in series. So R, and then this R and this R is your in parallel. So answer is RAB is how much? That is your R by 2. Again you see, this R in parallel, so this will be your R by 2. This R in parallel, so this will be R by 2. Now this R by 2 and this R by 2 are in series, so it will become R, and this R in parallel, so ultimately it is R by 2. In this way we can solve this question. It is the connecting wire. So if we will consider here the potential X, here is also the potential X, because through the wire there is no potential drop. Now here you see the arrangement. Here this is the circuit arrangement that has been given, and you have to find the RAB. So equivalent resistance, how can we find? Now you see, this is connected by wire, so these points have same potential, so these are in parallel, so it is R by 2. Similarly, it is R by 2. So what we can write? The equivalent circuit we can write So equivalent circuit we can write in this way. Now this is the popular format. You understand, this is point A, so here is the potential A, so this is also point A. This is point B, so this is also B, and here is also point B. So what we are getting? We are getting that here is the A, here is the B, one resistor is in this way between A and B. This is R by 2. One resistor is here, this is R, and one resistor is here, this is R by 2. Now it is very simple because it is parallel. So 1 by R equivalent, what can we write? 1 by RAB is equals to 2 by R plus 2 by R plus 1 by R. That is giving you 5 by R. So RAB is equals to R by 5. This is your answer. This way you can give the answer to this question. Now see this problem. Here 4 ohm resistor is there, here 3 ohm, here 2 ohm, here 4 ohm, here 5 ohm, here 2 ohm. Now in this question, one thing is to be understood very carefully, that this is your wire that is going. So this is not in parallel. This has got the zero resistance, so ultimately this will behave as a wire of zero resistance. So it will be simply treated as a wire. So 2 and 4, 2 and 2, 4, 4 and 3 are in parallel, 4 and 3 are in parallel. So what we can get? We can get 4 into 3 by 4 plus 3, that is this term, and plus 4 ohm, that is 12 by 7 plus 4, that is your 12 plus 28 by 7, 40 by 7. So RAB, in this case you will be getting 40 by 7 if the calculation that we have done that is correct. If some calculation error is there, you can correct it. So what is I want to tell you here, my main concept is there to make you understand that this concept of short circuiting, this is called short circuiting. So if short circuiting is there, then this type of combination gives you the zero resistance. That means it will behave as a wire. So you are not supposed to use this resistance. So 2 ohm and 2 ohm, 4 ohm, 4 ohm and 3 ohm are in parallel. So 4 into 3 by 4 plus 3, and then this 4 is in series. So plus 4, that is whatever is the value, that much ohm you are getting the answer. Now on the same profile of this short circuiting, we should see the next question, that is of the similar profile. Now here you see this question is of similar profile. Why? Here again the short circuiting is there. So when the short circuiting is there, you can observe that this resistance and this resistance has no meaning at all. It is simply like a wire, and it can be replaced by this circuit. It can be replaced by, because this is 0, this is parallel to this is parallel to this, so this term will be 0. How? You see 4, 5, 4, 5, 9. So R1 by R is equals to 1 by 9. R equivalent is equals to 1 by 9 plus 1 by 0 plus 1 by 2 to 4. So what you are getting? 1 by R is equals to, you are getting infinity. So R equivalent is equals to 1 by infinity, that is 0. So it is behaving like a simple wire. So this has to be removed, and then your combination becomes 4 and 2, 6, 6 and 3 are in parallel. So how much? 6 into 3, 6 and 3 are parallel. So 6 into 3 by 9, that is 2 ohm. So this combination can be replaced by 2 ohm, and this is 2 ohm, and this is 3 ohm. So R equivalent AB will be how much? 2 plus 3 plus 2, that is 7 ohm. This can be your answer. So this question of short circuiting I have introduced for your understanding, that you can understand the concept of short circuiting also. Short circuiting means connecting a wire, then the effective resistance, it behaves like a simple wire. So this thing also should be clearly understood by you people. Now see this network. In this network of resistors, 6 ohm is there, 12 ohm is there, 6 ohm is there, 10 ohm is there, 6 ohm is there, 7 ohm is there. You have to find RAB. Now in this question, you are seeing that these resistors are in parallel. So when these resistors are in parallel, what you are getting? 12 into 6 by 12 plus 6, 4 ohm. So this can be replaced by a 4 ohm resistor. So what we are getting? We are getting 4 ohm and 6 ohm in parallel, in series. So when 4 ohm and 6 ohm are in series, the result is 10 ohm. So this can be replaced by this network that is here, 7 ohm, 10 ohm, 10 ohm, 6 ohm. Now here you see, again this 10 ohm and this 10 ohm are in parallel. So 10 ohm and 10 ohm are in parallel. That means how much? This can be replaced by a 10 into 10 product by some 5 ohm. So this can be replaced by a 5 ohm resistor. So 5 ohm and 7 ohm are in series. So next diagram you will get five ohm, 7 ohm, and this is 6 ohm. So 7 ohm and 5 ohm are in series. So it is how much? 7 and 5, 12. So this will give you 12 ohm and 6 ohm. 12 ohm and 6 ohm are in parallel. So RAB, what you are getting? You are getting RAB is equals to 12 into 6 product by sum 12 plus 6. So 4 ohm is our answer. So 4 ohm is the, so again we should check once again. 6 and 12 are in parallel, so 4 ohm. 4 ohm and 6 ohm are in series, so 10 ohm, and 10 ohm in parallel, so 5 ohm. 5 ohm and 7 ohm in series, so 12 ohm, and this 12 ohm and 6 ohm are in parallel, so we are getting 4 ohm. This should be our answer. So I hope that this type of simple questions will help you for clarifying the concept in series and parallel, and then we will see one or two more questions on this same concept. Now here you see, this is the network and you have to find RAB. 2 ohm, 2 ohm, 6 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm, 6 ohm, 2 ohm, 2 ohm. Here you see the network. 2 ohm, 2 ohm, 2 ohm, 2 ohm, 6 ohm, 2 ohm, 2 ohm, 6 ohm, 2 ohm, 2 ohm, 4 ohm, 2 ohm, 2 ohm, 2. Now as this is the open end, so this has got no meaning at all. So we will leave this one and we will calculate the value from here. So 2 to 4 these are in series, and 2, 2, 4. So 4 is this, and 4 is this, and 4 is this. These three are in this 4, and this 4 are in series. So 4, 4, 4, that is 12. 12 and 6 are in parallel. So what we can write? We can write in this way the equivalent diagram we can write in this way. Now here see, 12 and 6 are in parallel. So what will be the result? 12 into 6 by 12 plus 6, that is 4. So this will be replaced by the 4 ohm, and this 4 ohm, this 4 ohm, this 4 ohm are in series. So 12, and here again 6. So this can be represented. This is your 4 ohm, 4 ohm, 4 ohm, and 4 ohm. 12 ohm, 12 and 6, again you are getting 4 ohm. So this whole can be represented by a 4 ohm resistor. So this is your 4 ohm. 12 and 6, 4, 4, 4, 4. 12 and 6, again this network is 4, 4, 2 and 2, 4, 2 and 2, 4, 2, 6, 4, 2, 6, 2, 8. So RAB is equals to how much? RAB is equals to 8 ohm. That's your answer. So this is also the thing that you should know and understand in a proper way. Now we will see one infinite ladder, that how to solve the problem of the infinite ladder. Find the current. Now here there is an infinite ladder. See, this goes to infinity. 1 ohm, 1 ohm, 1 ohm, 1 ohm. Now this is based on the concept of the problem of math that you have solved in your junior classes also, that infinity plus 1 is also infinity. And if we use that concept, now you see, this branch 1, 1, 1, this is repeated. So what I will do, from here to infinity, if I consider as x, resistance as x, then the equivalent diagram will be x 1, 1, A, B, 12 volt, 0.5 ohm. This is your 1 ohm, 1 ohm, 1 ohm. Now this I have considered the equivalent resistance to it. Now in this, if this is added, then also it is a x only. So see what I am doing. I am taking x and 1 in parallel. So x into 1 by x. This is the equivalent of this branch. So total branch is how much? 1 plus x. So x by 1 plus x plus 1 plus 1, 2. This is giving you equivalent resistance, and that equivalent resistance is how much? That equivalent resistance is again equals to x, because this I have considered as x. So this plus this is equals to x. So when this is x, what we can get? We can get x plus 2 1 plus x by 1 plus x is equals to x. This is giving you x plus 2 plus 2x by 1 plus x is equals to x. 2 plus 3x is equals to x plus x square. This implies x square minus 2x minus 2 is equals to 0. So you are getting a quadratic equation here. If you are getting a quadratic equation, x is equals to how much? X is equals to x, we have taken equivalent resistance. So x is equals to minus b 2 plus minus root under 4 minus 4 into 2 by 2. So what we are getting? 2 plus minus 2 root 3 by 2. So 1 plus minus root 3. Root 3 is 1.732. So 1 plus minus 1.732. Minus is not possible, negative is not possible. So it is your 2.732 ohm. This is the value of x, that is the equivalent resistance of this infinite ladder is given. Now in this internal resistance of battery has to be added. So RAB 2.732 ohm by plus 0.5, that is 3.232 ohm. So 3.23 ohm is the equivalent resistance. So I is equals to how much? I is equals to V 12 by 3.232. So this ampere, this much ampere, and this will be giving you 3.71 ampere. So 3.71 ampere is the current that is being drawn from the battery by this infinite network. I hope that this much amount of question that we have done on the series parallel concept will be sufficient enough to make you capable in solving any problems of series and parallel that will be asked in your examination. So with this much amount of practice, you will be confident in facing the examination in a proper way, and it will help you certainly, provided you do the practice and clarify your concept and then appear into the examination. Best of luck. Thank you.